Okay, YouTube, in this video we're going to be looking at the third and foremost, I guess, matrix operation. That'd be matrix multiplication. And in terms of matrix multiplication compared to the other operations we've seen, which are, I guess, addition, subtraction, and scalar multiplication, this one is not as straightforward as the other two in that when you multiply two matrices, and as you see here in this definition here, we have two matrices here, A and B, that are both these 2 by 2 matrices. The thing is, we don't just multiply them component wise. That is to say that we do not get this matrix, and let's go ahead and write this here. Let's go ahead and write we do not equal A times E in the first top corner here, B times F, okay, C times G, and D times H here. We would not get this product ever. And so what we're going to be doing is a different process actually that involves what we're going to call row by column multiplication. So when we talk about row by column multiplication, instead, to kind of take a look at how this works here, I've kind of given this screenshot of this definition. We'll take a look at the definition, but then we'll talk more about kind of the process behind it and why it just kind of makes sense in general to do it that way. So taking a look at this definition, again, we have these two matrices here, A and B, that are these 2 by 2 matrices, and they've been populated with the letters of the alphabet here. But what you see by row by column multiplication is simply this. When we talk about what kind of an answer we get here, well, in this case, we're taking a 2 by 2 times a 2 by 2, and we'll get into dimension later, but we get this 2 by 2 matrix over here. And by the definition of what we see here, essentially what we're doing in the first row, first column entry here, I'm going to put a little subscript here, first row, first column, is that we are taking the first row of matrix A times the entries in the first column of matrix B. And so the way this looks is that we take A times E, which is the first entry in this first row, times the first entry in this first column, and you just multiply them. So we get AE, and then what we do is we add on now BG. Where's BG come from? Well, we move over 1 in this first row, we move down 1 in this first column. So now we're taking the second entry in the first row times the second entry in the first column over here. But row by column, we get B times G there. And so I'm going to kind of delete these out here because I want to go backwards. But looking at the first row, second column entry in our product matrix here, you'll notice that we're going to take now the first row times the second column entries. And so this looks very much the same thing. We're going to take A times F this time, first entry in each row column pair here. A times F plus, now we move over 1 in the row, we move down 1 in the column, we get B times H. Again, the way this works is row by column. If we want the, now in our product matrix, second row, but first column entry, we would now take the second row in our A matrix times the second column in our B matrix here. Or sorry, times the first column because it is in the first column. So second row, first column, we just take C times E plus D times G. And then we would then, for our second row, second column entry here, we would take the second row entries here in our first matrix times the second column entries in our second matrix. And so what you're seeing here in a product is really we're using the rows of A times the columns of B. Columns of B. So this is like our row matrix in the product, and this is like our column matrix in the product. And what we're constantly seeing is that if we wanted, say, the entry in our product here that is in a certain row and column pair, then we will multiply that row in the first matrix times that column in the second matrix. And so a little bit harder to see over here. If we got a little bit clearer about it, we could look at these pictures over here where we've kind of only looked at this part of it. So again, when we look at just the first row, first column entry in our product matrix here, we would multiply each element in row 1 of A. So in our row matrix, we would multiply the elements in row 1 and times the column matrix here, the elements in column 1, and that would give us our row 1, column 1 entry over here. So we say A times E plus B times G. And as we go through our products here, we just kind of multiply, as you see color-coded here, by moving across and moving down in our row and column respectively. So as we multiply, we take A times E because they're the first entries in each, but then we move over here in our second entry of this row, we move down to the second entry in this column, and we would just keep doing this. And so with this process here, let's go ahead and take a look at how we could find a product on our own of these 2 by 2 matrices here, and I'll give you some advice along the way. So first things first, let's go ahead and write the order down here. This is going to be important as we generalize this in the next video so that we don't have to just say this only works for 2 by 2s. But I would say that A times B, I'm going to go ahead and write A times B, but I'm also going to go ahead and write these matrices side by side explicitly. So what we're really doing is we're taking 2, 3, 4, 7 as our A matrix, times this 0, 1, 5, 6. And so I'm going to go ahead and fill out my blank 2 by 2, and this is important. So here's the deal. I guess I would say find the dimensions of your product matrix first and fill out a blank product matrix here. And I'm going to write that down as soon as that pops up for me. So, spinning wheel of doom. Let's try this again. So I would say find the order of the product matrix. Then fill out a blank product matrix having spaces for each entry. So I guess what I mean by this is, with my new matrix over here, I'm going to tell you this video, it's going to be a 2 by 2, but what I would do first is fill out this product matrix, and I would put blank spaces in all of these spots where I know I'm going to have an entry. So since it's a 2 by 2 also, I'm going to get entries here, 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 and here. So the way this works is you first identify which entry it is that you're trying to find, what row, what column it's in, and you say, for instance here, the first row, first column, and then what you do is you mentally highlight the first row in this first row matrix and the first column in this second column matrix. And so what we get here is 2 times 0, since they are the first entries, plus, now we move over and we move down 3 times 5. So now to go backwards here, I just don't want these in the way. We're going to take 2 times 0. 2 times 0 is 0, plus, and you know what, I'm actually going to write this here. 2 times 0 plus 3 times 5 is what we get here. So now, this actually does come out to be a numerical value, of course, but that value would be 0, I suppose. 0 plus 15, we would get a 15 here. Now, do I have to write it this way all the time? No, but I'm showing my work here because I want to be explicit on how we're getting our answers. But we would normally just say 0 plus 15 is 15. So now, let's do this. We'll go first row, second column. So we're taking our first row entries times our second column entries. So we get 2 times 3, or sorry, 2 times 1. 2 times 1 plus, now we'll move over 3 times 6. 3 times 6. So here we get 2 times 1 plus 3 times 6. This comes out to be a 20. 20. So now let's do this. We go second row, first column. So we'll highlight mentally our second row, first column entries, and we'll start at the beginning of each. So 4 times 0, so we get 4 times 0. Plus now we'll move over and we'll move down in this column. We would say 7 times 5. So 7 times 5. And so we would get 0 plus 35. This is 35. And then last but not least here, we would take our second row times our second column entries here. And I can just go ahead and highlight these now since this is the last time we have to multiply. But second row, second column, we'll take 4 times 1. So 4 times 1 plus, now move over, move down. We'd say 7 times 6, 7 times 6. So here we get 4 plus 42, so we get a 46. So this would be our product matrix right here. So what I want you to try on your own here is take these two 2 by 2 matrices times each other and check out what you get. Cheers.